Welcome all to the workshop Research and Teaching with Onshape. My name is Stanko Škec and I'm assistant professor from University of Zagreb. And to be honest, I really feel privileged and happy to chair this session. So just to give you a short intro, many of you probably heard of or maybe used Onshape during the recent period. So during the pandemics, different digital cloud-based tools emerged as very important and very helpful for different educational institutions and industrial companies. As one of these, Onshape had an important role for CAD education and research, to be more precise. So also, I believe that many of you encountered some success stories or lessons learned on how Onshape actually helped people going through pandemics and virtual education. From my personal perspective, I can say that back then we were one of the proud, very early adopters of Onshape in European context, and its collaborative and multi-user functionalities helped us and caused many benefits for our research, but also education and our students. So for that reason, I'm really happy to actually introduce you to Dr. Matthew Mueller, who is Manager of Education Innovation from PTC. Today, he will show us and explain how Onshape differs to, let's say, more traditional CAD platforms and how engineers and researchers can actually benefit from newly accessible data for improving and for exploring their design and innovation process. Dr. Matthew Mueller, he obtained his bachelor and PhD degree at Tufts University, where he was heavily involved in both research and teaching activities, and also received even some awards for it. So this session will be divided in 3 parts. So we will have introduction presentation, then 50 minutes of demonstration, and then discussion and Q&A session. So I would like to invite Matthew to start, please.
Great. Thank you very much, Stanko, and thank you everyone for joining. I'm very excited to be here today. And I think the main goal that I'm hoping to get across today is that Onshape is fundamentally different than other CAD platforms. And yes, it's very accessible and great for collaboration, but there's so much more to it that's different from regular CAD. So to start, I'll talk a little bit about how Onshape is in fact different and what that means for designers, engineers, researchers. And then we'll spend 15 minutes or so actually doing a demonstration, and I'll highlight some of the things that are fundamentally different about how Onshape works in terms of data management, collaboration, and configurations. And then hopefully there should be plenty of time at the end for questions and discussion. So I like to start these kinds of talks with taking a step back and talking a little bit about the history of mechanical CAD and where we're coming from. So over time, each kind of new generation, each disruption in how mechanical CAD works has followed an advance in computing technology. So the first kind of commercially viable mechanical CAD system came out in 1981. That was CATIA, or CADS 4, and that was following the availability of mainframe computers. Now, this first version of CAD was very expensive, wasn't even a parametric CAD, and it only really made sense for big industrial companies, aeronautics, auto, heavy industrial companies to use this. And there were only thousands of users at this point with the first version of CAD. The next generation of CAD came in 1988 with the availability of Unix workstations. So these computers were much more available and much cheaper. And this was actually what PTC came from. It was a product called Pro Engineer. Now the name is Creo. And this was the first parametric version of mechanical CAD, but still was quite expensive for each user. And again, only really made sense if you were doing a pretty in-depth design, machine design kind of process or medical device, that kind of things. But it expanded the commercial base by an order of magnitude. Then the next disruption in the CAD world came in 1995, and that followed with the available of personal computers. So this is SolidWorks. This is a screenshot of what it looks like, and this is kind of where we are today. This is the industry standard, and the cost was lowered pretty significantly, and it provided access to smaller companies, startups, and again, expanded the commercial base by an order of magnitude. And that's kind of where CAD has been for the last 20 years or so. But what Onshape is planting a flag in the ground is saying this is the fourth tech disruption. Onshape was founded in 2012, first publicly released in 2015, and this is following the new advance in the availability of cloud computing. Again, Onshape has lowered the cost significantly in how available CAD is and made it useful for everyone, students, engineers, and development teams that go beyond just engineers, marketing, all different aspects, different members of the development team can now have access to CAD. And again, expanded the commercial base by an order of magnitude. We have almost 2 million just teachers and students that are using Onshape, which is a pretty staggering fact. So in order to understand how Onshape is fundamentally different, I like to give a little peek under the hood. I'm going to get a little bit technical, but hopefully just to show what is different. So traditionally, with the state of CAD today, each application is downloaded on a powerful workstation, and you need a computer with certain minimum specifications to be able to run the graphics and do all the processing. And when collaborating with a team of engineers or developers, you have to figure out some way of coordinating each of the files that you're working on with the CADs. And typically there's some central file system that you have to check in and check out files as each person is working on them. We're seeing a movement in the industry that these traditional CAD companies are adding a cloud component to it. And there's a couple of ways that we're seeing cloud-enabled CAD come to market. The first version is hosted CAD. So in this case, it's essentially the same basic architecture of CAD with a central file system for collaboration. But now you're hosting your application on a remote desktop that's running in the cloud. But you still have to check in and check out files as you're editing them, and document changes can still conflict. And the other approach that we're seeing is what we call the thick client. So you still need to download a CAD application onto your computer, which means that you need a computer with minimum specifications, powerful enough graphics card to do all the computations. And here the data is actually being stored in a cloud database, but because the application and the cloud database are separated, you're not really taking full advantage of the cloud. So that's why John Hirschtick left SolidWorks and said, we need to start from scratch. We need to not create a cloud-enabled architecture, but a cloud-native architecture built from scratch to take full advantage of the cloud and be multi-tenant, just like all of the other cloud-native technologies that have advanced efficiency and collaboration for other business systems. So here with Onshape, everything runs in the cloud. So the client, if you're running it on a computer, is just a browser window, but it can also run on a tablet or a phone just as well. And it talks to this database. And that was part of the reason that PTC was so excited about acquiring Onshape, is they had this architecture for this state-of-the-art software as a service database that we're calling PTC Atlas, and is being leveraged for other products as well, but was core to Onshape's development. So this is enabling fundamentally new ways for product development to happen. And they're starting to use the same agile development practices used by software industry for product development. And it's really just changing the way that products are being developed. So how does Onshape do this? First and foremost, the way that the architecture is distributed means that Onshape is accessible from any device with a halfway decent internet connection. Doesn't even need to be a super powerful internet connection. It's much less bandwidth than a Zoom call, for example. And the two fundamental things that I like to highlight are the database. So Onshape uses the single source of truth that's fully secure. So everyone anywhere on the world, as changes are being made in real time, is working off of the same single source of truth. And this creates a lot of huge value drivers for industry to adopt this architecture. And the second is FeatureScript, which is a brand new programming language developed by Onshape for Onshape to talk in the language of CAD. So what does this mean for you, the end user? So in terms of the database architecture, each edit that is made to a document is stored as a flexible incremental change to the document. So rather than storing a new file and having to save every time, each time you edit something, only the change is being appended to the database. So this is what enables simultaneous editing. And as I said, with that append-only editing, you can always go back and restore the document to an earlier state. So here you can see each change that's made. So the phrase I love to say here is you can CAD fearlessly. You can do crazy ideas, and if it doesn't work out, you can always go back to an earlier version or micro version without any worry about losing a design. And part of this database architecture means that each element of the geometry has an internal unchangeable ID for documents, versions, tabs, everything. So these references are very robust and are not easily broken. And then feature script, that other kind of fundamentally new way of interacting with CAD, is this brand new computer language that is ultimately what generates the geometries in a part studio. So this is what Onshape looks like. We'll get into there in a minute with the demo. But the way that I like to think about feature script is it's essentially a function that will generate the part here. So if you create any part in Onshape, a fun fact, you can right click on the part studio, select show code, as you can see here in this GIF, and you get this panel that shows up on the right. And this is actually the code that defines the part. And if you click on a face or a part of the geometry, you'll see the section of code that actually generates that. So computation and computational design are core to how Onshape can accelerate design. This also means that configurations are very naturally built in. They're essentially inputs to this feature script function that generates your part. And this allows you to create first-class custom features and tables. So unlike other CAD systems where you can create macros, which are essentially recording a series of features in a row, you can create your own feature that is a first-class citizen in Onshape and works exactly the same as a sketch, extrude. And actually the library of feature script code that defines these standard functions you see in the toolbar is fully open source, MIT licensed. Anyone can open that document and create their own customized version of an extrude to optimize their workflows. So because of these core architectural decisions, Onshape has product data management, or PDM, innately built into the platform. You can link documents, you can link parts and geometries from one document to another without worrying about files. You don't have to worry about having the right updated version of your CAD application and, oh, the file was saved in an old version, has to be updated. All of the parts are just data in the cloud and can be seamlessly linked in very flexible, extensible ways. You have role-based permissions that can be changed in real time, and you can limit those based on what the use case is to protect intellectual property or create open source designs that anyone can collaborate on. And then we also have release management built in directly to the Onshape platform. So these are some of the kinds of practices that are important for students to understand and have competencies in when they're going into industry. And in the past with other systems, the technology just got in the way. It was so hard for students to actually engage in a release management workflow, but now it's just built into Onshape and it just works. The technology gets out of the way. Another huge opportunity, and we're not going to go too into this unless there's questions at the end, is the Onshape REST API. So for those unfamiliar, REST API stands for Representational State Transfer Application Programming Interface. And this is a wide standard that's used by almost any cloud-connected device these days. And it allows you to access Onshape's engine, the geometry server, the modeling server, directly with any computational workflow. Any code-driven process you want can interact with your design in essentially the same way that people can interact with the design. So this is opening up so many doors for research and optimization and customized workflows and integrations with product lifecycle management systems. So this is, I think, a huge driver that is really separating Onshape from other systems out there. So rather than just telling you about all of these things, I think it's much more important to show you what is different. So my goal here is not to show you kind of how modeling works in Onshape, although of course we'll do a little bit of that. But I want to show a few of the ways that Onshape is just fundamentally different. And the three main points that I want to get across is how data management is just directly built into Onshape, and there's no such thing as files anymore. You obviously can export files if you want, or import files if you want, but the parts in Onshape are just bits of data, and you can pull them, push them in so many ways. We'll also go into some collaboration. I have one of my colleagues standing by to help out with the demo. So that's one of the key parts of Onshape that's very different. And then I'll show configurations, another piece of CAD modeling, which is a very important competency, but traditionally has been very difficult for students to engage with because technology gets in the way. So with that, I will hop over into Onshape. So here I am in Onshape. This is what it looks like when you sign into cad.onshape.com. And here in the top left, I can click create and create a new document. So Onshape is a little bit different in that you don't create a file, you create a document, and all of your design elements can live within one document. So I'll call this Design 2022 Lego Truck. And that's what we're going to be making, a Lego truck, because we only have 15 minutes, and hopefully you can extrapolate with the basic concepts here into how you can use Onshape to make a real truck if you had more than 15 minutes. So when you create a new document, you start with a part studio where you model your parts with a feature list, and then you have an assembly. So traditionally you start by modeling parts, but here I'm actually going to start right in an assembly. And I'm going to insert some parts. So I'll start by inserting. You'll see the first thing that shows up is my current document. I don't have any parts in my current document, but I can actually go to other documents. And here we can see I can pull a part from any other documents I have in my Onshape, or I can come down and click public, and I can pull a part from any public document that anyone in the Onshape community has shared. So I'll search for Lego Spike Prime, and I'll see all of these documents that have been created. This one is the main one I usually pull from, and I can see there's these full robot assemblies that I can directly import into my new document, or I can come over to Part Studios, and here I will take this big Lego build plate, and I'll add that. That will be kind of the main chassis of our Lego truck. Now, this is a big document, so it might take a few seconds to load, but that's pretty standard, even if you have a installed CAD application, that it takes a little while sometimes for the program to think. And of course, as I'm sharing my screen and streaming a video call, it can take a little bit longer with the bandwidth. So this is where I twiddle my thumbs and try to stall. And there we go. So there's the chassis of my Lego truck, and I can click check to insert that. And once it commits, there we go. So there's the chassis of my Lego truck. And once it's loaded, it's loaded. So now I have a very responsive interface that I can move around and work with freely. So I'm going to import a couple other parts from that document. I'm going to import a peg that I can add a wheel to. So here I'll come down and find the peg here. So I'll take this Technic pin with axle, and I'll insert that into the assembly. There we go. And then I'll insert one more part at the same time. And this document, the creator did a great job of creating the full set of Spike Prime parts in this one document. And we're seeing FIRST robotics teams take a lot of advantage of this in designing their Vex robots or other types of robots in real time. So here I'll take this white wheel, I'll insert it, and there we go. Okay, so now I have my 3 parts that will be the start of my design. Maybe I will start by fixing my chassis so it will stay in one place. And then I can start using these mate connectors to create my assembly. So I will create a revolute mate between that pin and here. I'll make sure it's oriented in the correct way. And I'll click check. So now we have my pin in the correct place. Hopefully everyone's played a little bit with Legos and knows the general idea of how Lego works. Now we can fasten this wheel onto the axle here. Again, we'll make sure it's pointing in the correct direction and click check. So there we go. We have the start of our Lego truck here. Now, again, I've not modeled anything from scratch in this Onshape document. I've only been pulling from other places. But what I can do, because I know I'm going to want to make more than one of these wheels, is I can right-click on these 2 parts, and I can create a new subassembly from these 2 parts. And move to new subassembly. So there we go. We see them collapse in here, and we see this new assembly appeared in my document. So you can have as many assemblies or part studios as you want within one document. And again, you can seamlessly link these part data between documents, which is a really powerful way of modeling. So now let's make sure that we have 4 wheels so I can replicate this assembly instance. And I will select match individual edges, and I can click the 4 edges on the corners of this chassis here. And there I have my 4 wheels. So we have the start of a car. And now what's a car without tires, right? So now we can get into the fun part, which is actually creating a model. And one of the very exciting things that Onshape allows is you to model in context. So I want to create a tire for this wheel in particular. So why not create it in the context of this assembly? So I created this mate connector, which will be the origin of my tire. So now I can select create part studio in context. It asks me to select the origin mate connector for my new part studio. So I'll select that edge of the wheel here. And when I click check, again, we see a new part studio has just appeared in my document, all within this same container. So now we see there's this kind of translucent assembly in the background. I see assembly 2 is displayed, and I can change that transparency if I want. But this is a brand new parts studio, no features. So as with all CAD, we start with a sketch. I'll create it on the top plane, go normal. And I can actually pull entities into this sketch from my assembly. So this is the use feature in Onshape, and I can just click this edge. I don't even know what the dimension is, but I know that it's the exact right dimension because I trust whoever modeled that Lego part made the right size. And then I can also create another circle, and maybe I'll dimension the outside here, and I'll create a variable in this case, and I'll say tire diameter. And we'll start with a 2-inch tire diameter. That seems about right for a Lego truck. And this is a great way of making sure your design is very parametric and flexible based on what you want. So now, as with most CAD models, I can extrude it to go from 2 dimensions into 3 dimensions. And again, rather than having to look up the specification for how big this wheel is, I can use the context of that wheel to make sure that the tire is exactly the right thickness to go around the wheel. So there we go. I have the start of my tire. And then last but not least, let's create some tread so the tire has some grip on the ground. So I'll create a sketch on this face. I'll create a little rectangle, make sure that it's properly constrained to the edge here. And I'll just choose a pretty arbitrary size to start with. So there's my sketch. And now I can extrude, remove this part of the sketch to create a cutout. That will be the first part of my tread. And then last but not least, I will create a feature pattern. So I'll come over here, find the circular pattern. And rather than create a part pattern, I'll create a feature pattern. And I'll select this extrude to. I'll select the edge of the tire to be the axis of my pattern. And maybe let's start with 30 cutouts to be the start of my tire. So I can click check, and that looks like a good start to the tire. So I can click here, insert, and go to assembly. I'll insert part 1. And of course, if I was following best practices, I would rename my parts as I went. So maybe I'll do that. So I can right click on part 1, rename it, call it tire. And I could even rename this part studio and call it the tire part studio. Here, maybe I'll rename this assembly 2 to be wheel sub assembly. And the last thing I need to do is mate the tire to the wheel, because we haven't done that yet. So I'll select the tire and I'll select the wheel. Now they are fastened together. And immediately when I come into my assembly 1, I see all of these changes have instantaneously propagated through the design because we're working off a single source of truth. Everything works in real time. I see one question has come in about compatibility with different computers. Again, it all works on the internet, so no compatibility issues. It's all just data in the cloud. So as long as you have an internet connection, you can edit in real time on an iPad, on an iPhone. It all just works. Maybe I'll take a quick pause. Everything coming across clearly so far?
Okay. I believe so, yeah.
Great. So this is kind of the data management part of the demonstration. I wanted to show that everything just works. It propagates through in real time. You can link parts from other documents and model assemblies with other parts very easily. And now we're going to get into the collaboration part. So here I'm going to share this document with my colleague Alex, who's standing by. And as soon as I click share, and again, I can select all of these different permissions. So you can be as restrictive or available as you want them to be. And Alex should have just gotten an email, and in a second, I suspect I'll see him pop into this document. And I can add a comment here. I can say, Alex, can you please add a fillet to the edge of the tire? And maybe what I'll also do is come into the tire here, and I'll tag an entity. So I'll say it's this edge of the tire. I want to make sure he knows what we're working on, and I can assign that to Alex. Now I'm going to come over here. I'm going to create a version. So everything is very version controlled in Onshape, just like GitHub. And I'm a busy guy. I want to take full advantage of the engineering team. So as Alex is getting in here and starting to work on that, I can create a branch and start to work on my own on a new thing. So Alex is still in the main workspace here, working on adding those changes. And I'm here in a new branch, and I can make my own edits without worrying about creating conflicting changes with Alex. So here's my tire. And the next thing I want to show is configurations. So on the right here, I have a configuration panel. I can click Configure Part Studio, and we start with default. And then maybe I'll create a high tread version. And then I will also create a low tread version. And for this configuration option, I can configure a feature, and maybe I'll configure this circular pattern 3, and I'll configure that instance count. So we see this number shows up here, and I'll start with that. So maybe for the high tread version, we have 40 of these pattern cutouts, and for the low tread version, we have 20 of the pattern cutouts. So now on the left here, we have this configuration panel that popped up, and I can select high tread, see what that looks like. I can select low tread, see what that looks like. And the powerful part is this is all the same part studio. It's the same feature script function that is made up of these parametric features. And all this configuration is an input to that programming function that generates different parts. So very flexible, very extensible. We can use all of these different parts. All of them exist at the same time, which is hugely powerful. So maybe I'll add one more configuration. This time I'll add a configuration variable instead of a list. And here I'll create a variable called tread depth. And maybe the default will be 0.05 inches, minimum 0 inches, maximum 0.15 inches. And now I have another configuration option is shown up here on the left. And I can edit my Sketch 2, and I can come in, I can dimension the depth of this with this variable. So I type hashtag and I see all the variables in my workspace, and tread depth is one of my options. So that's the thickness of my tread cutout. And again, I can just change this variable to be a low cutout or a higher cutout. And all of these different versions of the part exist at the same time. They're all just different inputs to my feature script function. So as I've been adding these configurations, we can go back into the main. So I've been working in this branch here. We can go back into the main workspace and see how Alex has been doing, see what progress he's made. So awesome. It looks like he's done some great work and added the fillets, and he's gone even further and added these holes onto the wheel as well to reduce the weight. So I think I'm ready to take my changes from my branch and merge them in here. So I can right click on my branch and select merge into current workspace. And as long as none of our changes created conflicts, we now have this updated version where I can configure the different tread counts to be high or low. And the tread depth can be 0.1, and it's all a fully configured tire. And we were making those changes in real time. And because of this GitHub style workflow, it's an agile product development process. So we were able to work in parallel on different things and then just merge the changes in. And as long as those changes didn't conflict, it just worked. The changes propagated through. So we can come back in, and again, it's a single source of truth. So all those changes have come into Wheel Assembly 2. I see that Alex has created this fun pattern here. And if we come in, I can see there's this new feature has showed up, and this fill pattern feature you won't find in the standard library here, because it's what we call a custom feature. So someone had a use case that they wanted to create a lot of these kinds of patterns and created their own custom feature, which is just a normal parametric CAD feature that can be used here. So all of these changes have come through, and now we have our up-to-date car that was developed in parallel by team members. Alex is based in Romania, I'm based in New York City, and we're still collaborating in real time. If I double click on Alex's icon here, I can, with no hands, see what Alex is seeing in real time. We can do a design review. We can do anything we want by collaborating across the world. So what have we learned? So we touched on how data management is directly built into Onshape, and I realized I wanted to show one other thing. So here Alex is moving the view, and I can see that, but as soon as I take control, we see things like bill of materials. It's just directly built in here, and I can add a column. Let's say I want to add the name of my parts into my bill of materials. Here it is. And the person that created this link document added actually the link to buy those parts from a Lego library. We see the names of all the parts. So it's all just directly built in. Collaboration across the world in real time, you can see that single source of truth change. And configurations, this powerful part of how CAD works in industry, students can now engage with so easily. The technology just gets out of the way. So with that, I will yield my time and see if there are any questions.
Thank you, Matthew, for a nice presentation and nice demo. I noticed there are a few questions in chat. So Alexander posed question: are there any features to create A-class surfaces? So if you could comment on that.
Yes. So surface modeling is, a first-class part of part modeling in Onshape, and as with all of the other features in the menu, that feature is fully open source. So you can see the code that is used, the feature script code that is used to generate all of these surfacing functions and create your own version of them. They are a little bit more involved than the normal kind of solid modeling, but there's other partner applications. So here you can come into applications, and there's an application called PHI that is a great kind of surface modeling interface that is, through the REST API, very seamlessly integrated with Onshape.
Okay, great. Thank you. And one more question from Peter. So what are the main differences between Onshape and the approach that Onshape had integrated with Fusion 360?
Great question. One of my favorites, actually. So what Fusion 360 is this thick client approach that I talked about, where you still need to download and install Fusion 360 on your computer if you want to edit the model. They have a web viewer of your models, so you can see the model in the browser, but you can't actually edit that model in the browser. And with Fusion 360, you don't have any of these other directly built-in data management capabilities. You have some, but not to the same extent. And you don't have things like real-time collaboration. You don't have feature script to create these first-class parametric features. So it really is fundamentally different. We like to say that Fusion 360 is cloud-enabled, but it's not cloud-native. They had this CAD application and integrated it with the cloud, but they didn't build it with the cloud in mind to start.
Thank you once again. So I have one question for you, Matthew. So since there are actually, I think, plenty of researchers here actually among participants of this session, I would like to ask if you could provide more details about Onshape analytics. So I think there are many strengths that Onshape offers, and especially for design researchers, that they're very interested to analyze how people actually collaborate, how people work during design process using, for example, CAD as one of the main tools. So could you please explain that a bit more?
Yes. So as Stanko mentioned, because of Onshape's cloud-native architecture, we see every change that's made to the document. So here, I can come back to any individual part or any individual edit that was made at any point in time. This goes back infinitely. I can go back to the first insert of a part that I did. Each change is saved as a micro version. And this is part of that append-only database architecture. So this means we can track who is making changes, what kinds of changes they're making, and aggregate those in analytics. And of course, you can track all sorts of things. But one of the limitations is you can only access that as a user through an enterprise. And there's an EDU enterprise option. And if you're interested, please reach out. A couple of my colleagues, Bernard and Alex, can help with that. I see Bernard just put a link there. Thank you. So with a EDU enterprise, you get a new domain. And this is a number of advantages. You can use single sign-on for your students. But one of the advantages is access to this analytics. So you can come and see my activity. So I can see, as a designer, what have I done over time, and which documents I've worked on, what types of edits I have made. We could see my top 10 most active documents, all that kind of stuff. Over time, we can see, let's see what filters we have now. I don't know if this is the last week or what, but one of the main ways that researchers are starting to take advantage of these analytics is through the audit trail, which is every single change that's been made to any document within the enterprise. You can see all of those changes and who is making those changes based on the time. And you can export this just as a CSV and do some very exciting analytics to understand how students are learning, or how professional design teams are collaborating in real time. So yes, that's a very powerful way that researchers are starting to leverage Onshape's cloud native architecture.
Thanks. Well, we have a question from Nicolo. So he asked, how many students can concurrently work on the same document fluently? So are there any limitations and restrictions in terms of that?
So, you know, there, at a certain point, you will possibly see some reduce in performance, but there's no real limit. And the main limit really is in multiple people editing documents at the same time. So if you just want people to view the document, I can actually just put the link to this document in the chat here, and that's a view-only version. Anyone can just click on that, and even if you're not signed into Onshape, you can click through the tabs, manipulate, you know, move around the model, and see everything that's there. So again, if you want to have 200 plus students in the same document and they're all editing the document, then there will probably be a slight reduction in performance. But there's other ways and certainly lots of best practices for how to optimize the performance of your designs by distributing parts among different documents and linking the parts between documents. And if you're getting to that level of big assemblies, we can certainly work with you to make sure the performance stays optimal.
Okay, great. And so we have one more question from Professor McAloon. So he asked about integration of designs for sustainability plugins and tools. So for example, LCA, like life cycle assessment, material selection, etc. Do you have some types of these sustainability plugins and tools integrated already in Onshape?
The short answer would be yes, I'm sure they are available here. And here what I just clicked on was the App Store. And you can see all of these are first-class citizens of Onshape. They integrate with Onshape's REST API, and I'm very confident there's some sorts of sustainability analyses or manufacturing kinds of applications that can help you understand those things. But beyond that, because you can access the geometry in real time through the REST API, you can do your own analysis, your own customized analysis. You could even do that with a custom feature in FeatureScript to understand the mass properties, the material choice, any of that. And it all leverages that same cloud native architecture. So if exactly what you're looking for isn't there right now, it's easy to create that first-class citizen integration through FeatureScript or the REST API.
Great, thanks. I would just like to ask you, is there maybe we have time for one very last question, if there is some additional questions, if someone is willing to ask something via chat or yeah. So Matthew, do you have some message for the end of the session?
Well, first I will thank you for having me. This was a really exciting event, and I'm very happy that I got to participate. And I look forward to seeing the main event throughout the week. Here's my email, so if any questions come up, please feel free to reach out anytime. And I think the main thing I want to make sure everyone walks away with is that Onshape is not just a CAD platform that runs in the cloud. Onshape is a fundamentally different way of doing CAD and doing product design. It's not just another CAD application. It's totally different and opens up a whole world of possibilities for how you can do product design in new ways.
Thank you, Matthew. Thank you for a great presentation, demo, and Q&A session. Thank you again. Oh, we have one more question from Peter Torling. Could you please explain the academic license and what it covers?
So the academic license, the educational plan, is full modeling functionality and data management functionality. The App Store integrations, there's a number of different options here. And you see there's a bunch of different kind of setups with how they're offered, but almost all of them have at least some free offering that can be used by educational plans. So for example, this SimScale application is a cloud-based simulation engine that you can directly import your model from Onshape into SimScale. No downloads, no anything. And as you change your model in Onshape, you can update the SimScale simulation to take that new version and run the simulation again. So the educational plan is the full functionality of modeling, collaboration, data management. And as Onshape creates and develops more integrated functionality for simulation and rendering, we are eager to try and provide that for education users. Of course, with the almost million active education users, we have to consider the scalability of resources. But we certainly, as Onshape continues to be developed, will look towards providing all of the functionality we can to education users. But again, I emphasize there are solutions readily available and free for you to use right now through the App Store. So maybe a super quick example is if you're looking to do digital fabrication, there's this application called Kirimoto, which just shows up again as another tab in your Onshape document, and you can import your parts directly without worrying about any changes or anything, and generate your CNC toolpath or 3D printing. But of course, you can export the part and bring it into any third-party application you want. A long answer to a short question.
Thank you, Matthew. Thank you all for participation, for great questions. I think we heard some very nice information, and I think we get many new insights about Onshape and how it can be used. Well, thank you once again, Matthew. To all participants, we're looking forward to new sessions tomorrow. Hope you enjoyed the workshops today, and see you tomorrow. See you tomorrow.
Thank you.
Thank you. Bye.